Hello, on this video I want to talk about Python's list. So list is a collection of items that can be stored in one variable only. The list is ordered but not necessarily sorted. You can mix data types within the list, you can repeat lists, and also it's immutable. In other words, you can add and remove items anytime you want. Alright, so let's create a list. The simplest way is to just and 9. So that's the simplest way to create a list, and then you can print this list and it shows you the items inside your list. You can also create a list from a string. So let's say I have the word Seattle and I want to convert every single character of Seattle into the my list. So in this case, I'm just gonna cast into lists, and now I have every single item separated in my list. And you can also convert numbers into the list. So let's say I have 1, 2, 3, 4, 5, 6, and I want to convert this into the list. You convert just as fine. However, in this case here, it got converted to characters, not into integers. So if you want to convert that into integers, you can use the map function and then int, and that will convert everything to integers. So now if I run the program again, you'll notice that the single quotes went away. That means now I have a integer. But what if I have a mixed values within integers that are not integers? So if I do that, I'm gonna have a problem. So to solve that, we just need to change here a little bit, and the way I do that is my string. I want to copy here this value so I can create a new variable, just so it's a little easier to understand this whole process. Now on the list, I'm going to create the int, and I'm going to create the characters, and I'm going to loop through this string here. So for each character into the my strings, and then I'm gonna put a if here, if each character is a digit. So now what this does, it checks if it's the digit before it converts to the integer in order to save into the list. And now if I run this program, make a mistake, if I in, all right. So for C in my string. So now if I run this program, I have all the numbers in integers and all the known digits got removed from this list. All right, so now instead of creating the list, let's take a look on accessing the elements or the items from a list. So I'm gonna create the list again. So let's say my list is, so the first way for us to do that is by index. So if I want to access, let's say number 5 only, the index of 5 is 1 because Python is a zero index language. So the index of 0 is 0, and here is going to be 1, 2, 3, 4. So I can access this item by index. So if I want to access number 5, I want to pass index 1. So once I print it, I print 5, and if I want the number 6, there will be index 0, 1, 2, 3, 4. So if I pass index number 4, it prints just fine. All right, so what if I try to access an index that doesn't exist? So let's say I'm going to try to access index number 10 here. So 10 obviously does not exist. So if I try to run, it gives me index out of range or index error exception. Now, one interesting thing here is I'm going to print the 0 again just to show you that the number 0 shows up. Now, if I put -1 here, it goes back to 6. So that is interesting for me. So if you try to access with index numbers to the right of the list, it will give an error. But if you try to access with the index numbers to the left of the list, it will start from the right to the left. So if I do number 2, for example, it will print the 3 here. All right, so the other way is doing a slicing. So slicing is when you get a range of items from your list, and then it takes two parameters. One is the start, which is inclusive, and the other one is the end, which is exclusive. That means if I pass the parameters, let's say 1 here, and let's say 0, 1, 2, 3, it will take the number 5, which is index 1, and it will end at index number 3, which is 3. However, the end is exclusive, so it will not include number 3. It will include number 5, and we will include number 2 here. So if I run, I get 5 and 2. What if I go again out of range to the right here? 7 is definitely out of range. It will go out of range, but you will not get your arrow, and it will print all the way here. So if you want to put 70, which is obviously out of range, and it will still just work fine. Now, what happens if people go to the -1 here? Will that work? Yes, it will work as well. So on the slicing, there's no problem going too much to the left or too much to the right. But when you are accessing individual item, there is a problem there. All right, so let's go now to update items in the list. So let's say you still have the same list, and I want to update the first item. So I'm going to use my list, and I'm going to use the index. I'm going to get the index of 0, and then I'm going to change the value to 22. So I'm going to print the list here, and then I'm going to print the list again at this point. So on the first time you print the list, it printed just fine. On the second time, the index 0 got changed. So now I want to add by the function append. So in order to add with the function append, I'm going to put the dot append here, and then the value I want to add. So this time I'm going to add the word dog. So when you use append, you will add at the end of the lists. Now, if you do not want to add that by the end, you can add by insert. So instead of append, I'm going to put insert, and then I'm going to put the index of where I want the word dog to go. But let's say I want to insert between 5 and 2. So if that's the case, I'm going to pass index 0, 1, 2, and then the word dog is going to be in between 5 and 2. Now, if I want the word dog to go between 3 and 6, then I'm going to put the index of 6, which is 0, 1, 2, 3, 4. So index number 4 will place the word dog between 6 and 3. All right, so let's take a look on remove. So instead of insert, I want to do a pop, and the pop will remove by pop. And it will remove the last element. In this case, it removes 6 for me. You can also give a location by index. So let's say I want to remove the number 5. So if I pass a 1 here, which is the index of 5, I'm going to remove 5 from this list. So if I print, now 5 is gone from this list. And the last way to remove is by value. So let's say I want to remove the number 2 from this list. I'm going to put number 2 here, but instead of pop, I'm going to put the word remove. So this will remove by value. You will find the first value of the number 2 and remove it. So the number 2 is gone. Now, just in case, if I had 2 number 2s on the list, just in case, then in that case, you only remove the first occurrence of that 2. So if you notice right here, the first occurrence got removed, but the second one did not get removed. Now, what if we try to remove a number that doesn't exist here? So let's say I want to remove number 9. So number 9 does not exist on this list. So if I try to remove number 9, I'm going to have a problem. It's an error here. At this point, you have two options. The option number 1 is to put a try here, accept, and then you can print a friendly message here saying, I can't find the target. So now this is a friendly message. Now the second way for you to do the same thing is to use a if. In other words, to check if the target is in the list. So in order for me to do that, I'm just going to put an if statement here. So let's say my target is 9. So if 9 in my list, then I can actually remove the 9. So this is by try accept, and the second way is checking before you remove the item. So both ways are going to work just fine. So the first one, I can find the targets, and the second way does not give an error. So if you want a message right here, you can put else and then target either. So I can find a target either. So you can use this way of checking before you remove, or I can use this way to use a try catch. For me, if something never fails, let's say if this rarely fails, I prefer using the try catch or the try accept. If things fails often, I prefer using the if to check if the target is there before you remove it. I don't think there is a lot of difference as far as performance is concerned, but generally speaking, for me, again, I prefer to use the try accept when I know that this will rarely fail, and if I think it's going to fail often, I prefer checking with if before. All right, so let's cover another topic here, which is most operations, or let's say most common operations within lists. All right, so the first one that I like here is to check the length of this list. So to do that, just put the word len here, and this function will give you the length of this list. So the length of the list is 6. The membership. All right, so to check for membership, so I'm going to create an if statement. If, let's say, 5 in my lists, then I'm going to print found it. Else print nope. All right, so in the case of 5, found it, and let's say if I pass the number 9, which is not there, nope, it does not find it. So that's how you check for membership of a item in the list. All right, so the other item that I use frequently is called the repetition. So whenever I want to create a list and I want to have a list of all zeros, I can do a repetition by just multiplying that. So now if I print my list, you're going to notice that I have a bunch of zeros in this list. And this can be as long as you want. It will replicate that value within the list. All right, so I'm going to put the list back to some lists. And now I'm going to show you the loop by index. So let's say you have that list, and then you want to loop through this list. You can do it this way for I in my list, print I, and that prints every single item. However, I also want the index of every single item. So for that, I'm going to put the I, comma, value. And then I'm going to enumerate this list And then I'm going to print the I and the V. So now the I is going to be the index and the V is going to be the value of whatever I'm trying to pass. So now I have the index next to the value, index, value, and so on, so on, so on. All right, so the next item that I want to show you is the sorts. I use the sort very often as well. So in this case here, this list is not sorted. So to sort that is quite easy. I'm just gonna get the list dot sort, and then I can print the lists, and then you're gonna notice that the list is sorted. Just note that this is not a cheap operation. Sorting, generally speaking, in any language, in anywhere, is a very expensive operation. So in this case here, I have very little items, so you're not gonna see a performance issue here too much. But if this item had, let's say, 10,000 items on this list, then you start having a little bit of problem with sorting. And if you have, let's say, 1.5 million items, then it might take a long time, like hours or maybe even days, to finish sorting a list that has an extremely large amount of numbers. So depending of the case, it might not even be doable. So be careful with the sorting. All right, so the last item I want to talk about is concatenation. So concatenation of lists. So I'm going to create two lists here, very simple. So I'm going to create the list, the inner lists, and then I'm going to create my A list. The A list is going to be 10, 20, and 30. And then now I'm going to create the X. So my X is going to be a combination of the inner plus A list. So now I'm going to print the X, and then I have the combination of both lists. Now I'm going to try to show you here a problem that comes with shallow copy and deep copy. So in this case here, I have a list and another list, and then I concatenate the two lists together. Now, if I go to the inner list now, and I try to change that thing, I'm going to append the word banana here. And then I'm going to print the X list again. And now if I run this guy, I have exactly the same value here. Because when I create this way, it created a deep copy. So I copy the inner lists and the A lists into the X. Then I changed the inner lists, but the X list did not change. So this is a deep copy. However, if I change this slightly, so let's say instead of having X at inner, I'm going to create another one here, and this is going to be my B list, which is equals the inner list. And then instead of creating the inner here, I'm going to press the B list. So now I'm creating the X lists a little different, but I'm still doing exactly what I did before. So I'm just printing the X list, then appending something on the inner list, then printing the X list again. So in this second case, the X list got changed. So the word banana was included on the X list, even though I did not change the X list. I just changed the inner list. But when you create a concatenation this way, you're going to create what's called the shallow copy. So this is referring to your original inner list. So if you change the inner list, then your X list will change as well. So this creates a lot of confusion. And honestly, I do not remember all the cases where it creates a shallow copy or it creates a deep copy. So to avoid any problem for me, I always create a deep copy with the copy library. So in order to use the copy library, I'm going to import copy, and now I can do this copy with the copy library. So instead of using the inner right here, I'm going to do a copy dot deep copy, and then I'm going to pass the inner list as a parameter on the deep copy function. So now if I run this program, the banana went away here. It went away because now it created deep copy right here. All right, the second way for us to solve this is, instead of doing a deep copy right here, you can also do a deep copy when you do the concatenation. So we can use the same function right here and do a deep copy when you do the concatenation. So that will not have your banana here because it created a deep copy. So the deep copy can be used to concatenate two or more lists, or when you're copying a list into another list, you can also use the deep copy, and it will create, well, a deep copy instead of a shallow copy for you. So for me, I do not want to memorize, and I don't memorize every single case where it creates a shallow copy or deep copy for me. So I always use the import copy and then the deep copy function to copy the lists whenever I have to. All right, so that's all for this video. Thanks for watching.